Hello, my dear student. Today I am going to discuss about Edexcel IGCSE O-level physics chapter-wise question paper solution. Today I will discuss about movement and position. Question paper 1. Level 1 IGCSE 9 to 1 Subject Physics Brand Exam Board Edexcel IGCSE Module Double Award Paper 1 Topic Forces and Motion Subtopic Movement and Position Booklet Question Paper 1. I am Jahangir here. Total marks in this paper 51. First question. A toy car rolls down a ramp and hits a cushion. The graph shows how its velocity changes with time. It is a velocity time graph. A constant velocity on the graph is shown by option A, area under the line, option B, horizontal part of the line, option C, sloping line at the end, option D, sloping line at the start. So remember, it is a velocity time graph. Velocity time graph, here in the first question, the velocity increases with time, so it is not a constant velocity. So in second part or middle part, the velocity remains same or constant. So the horizontal part of the line, so answer will be the horizontal part of the line. So constant velocity on the graph is shown by the horizontal part of the line. Horizontal part of the line. So remember, if the velocity time graph is horizontal to the time axis, then it represents the object moves with constant velocity. Then distance is shown by the distance. Remember, distance area under the line. Remember, because we know distance equal to speed into time, speed into or velocity into time, speed into time. That's why distance equal to area under the velocity time graph. Velocity time graph. So here answer will be the area under the line. Question number 3. Look at the question number 3. The average velocity of the toy car is given. Average velocity. We know average velocity. Remember, average velocity equal to average velocity or average speed equal to total distance moved, divided by total time. So answer will be B, the distance moved divided by time taken. So average speed equal to, or average velocity of the toy car equal to distance moved divided by time taken. So now there is a model answer here. Look at the answer. So on the velocity time graph, the area under the line gives the distance traveled. So on a velocity time graph, the area under the line gives the distance traveled, and the greater the line that gives the, so if the area under the velocity time graph is more, then the distance traveled by that portion is more, and the gradient of the line gives the acceleration. Remember, so there are two things here from a velocity time graph. So distance equal to area under the, remember, distance equal to area under the velocity time graph, area under the velocity time graph, remember this thing, and acceleration equal to gradient or slope of the line. Here another important thing, the sloping lines on the graph show that the velocity is changing over time. So the sloping lines of the graph show that the velocity is changing over time, because the value of y on the graph representing the velocity is constantly changing as the value of x representing the time changes. The horizontal line is the constant value on y-axis as the value on the x-axis changes. So it represents one velocity as time progresses, including that the velocity is constant. Therefore, answer is B, the horizontal part of the line. So here answer will be B, the horizontal part of the line. Now distance travel is shown by option A, area under the line. So distance travel, area under the line, and average velocity equal to distance traveled, distance moved divided by time taken. Total for question 1 is 3 marks. Total. Very basic question here. Now question number 2. A racing cyclist practices by riding around a round track. So a racing cyclist practices by riding around a track. A student wants to find the average speed of the cyclist. Describe a method that the student could use to find the average speed. Read the question first carefully. A racing cyclist practices by riding around a track. A student wants to find the average speed of the cyclist. Describe a method that a student could use to find the average speed here. Five marks in this question. 5 marks. So now there is a model question, a model answer. Okay, you could measure the track using either the track length given by the venue. So you could measure the track using the either the track given by the venue or by the measuring with meter tape or measuring tape. measuring tape, measuring tape. Stopwatch could be used to measure the timing for a lap. So student could use the stopwatch to measure the timing for a lap. Multiple laps could be measured accounting for the reaction time of pressing the stopwatch. So multiple laps could be measured accounting for the reaction time of pressing the stopwatch. We know average speed equal to distance moved divided by average speed equal to distance moved divided by time taken. So here distance moved means circumference of the circular track, circular or round track. So the average speed can be calculated by measured values. So 5 marks here. Remember, there should be 5 points. First, you or student could measure the track using either a track length given by the venue or by measuring with a measuring tape. Stopwatch could be used to measure the timing for a lap. Multiple laps could be measured accounting for the reaction time of pressing the stopwatch. Average speed equal to distance moved divided by time taken. So the average speed can be calculated by measured values. Total for question 2 is equal to 5 marks. 5 marks here. Now question number 3. Read the question first. An aeroplane takes 2 minutes to travel the short distance between airport on 2 islands. An aeroplane takes 2 minutes to travel the short distance between airport on 2 islands. The graph shows how the speed of the aeroplane changes as it takes off, flies across the sea, lands on the other island. When it is flying across the sea, the aeroplane travels at constant speed. Use the graph to answer the following question. State the value of constant speed. Here. Look at the graph. Speed in meter per second. So speed in meter per second here. Speed in meter per second. 10 meter per second, 20 meter per second, 30 meter per second, 40 meter per second. So is about 42 or 42 meter per second or 42.5 meter per second. So model answer. The constant speed is about 42 meter per second. As this is the flat part of the graph. The flat part represents where this is a constant speed. So when the velocity time graph is horizontal to the time axis, then it represents the plane moves with constant velocity for that time. So answer will be 42 meter per second, because here about 42, about it is 42 meter per second. So answer will be 42 meter per second. 42 meter per second. Now calculate the acceleration of the aeroplane at the start of the journey and give the unit. We know acceleration denoted by small a equal to slope or gradient of the line. So slope or gradient here in y-axis there is speed or velocity, change in velocity divided by change in time. That means final velocity minus initial velocity divided by time. Here final velocity achieved 42 and initial was 0, and time here it is 20, so 5, so here it is 15 seconds, so 15. So 42 divided by 15. So 42 divided by 15 is 2.8 meter per second. 2.8 meter per second. 2.8 meter per second square. Remember, the unit of acceleration is meter per second square. Why the unit of acceleration is meter per second square? Because acceleration equal to change in velocity divided by time taken. Unit of velocity is meter per second. There is another second here. That's why unit of acceleration is meter per second square. Meter per second square. Remember, this thing is very important. Meter per second square. So 2.8 meter per second square. Unit of acceleration is meter per second square. Here answer 2.8 meter per second square. 2.8 meter per second square. So unit of acceleration is meter per second square. The slope of the graph is the acceleration, or rate of change of velocity is called acceleration. So slope equals to 42 divided by 15. 42 divided by 15. Slope equals to 2.8 meter per second square. So acceleration equals to 2.8 meter per second square. This is the gradient of the left part of the graph, change in y divided by change in x. So gradient equal to change in y divided by change in x. Remember, this is a formula or technique. Slope or gradient equal to change in y divided by change in x. Now question number 3, total distance that the aeroplane travels. We know distance equal to area under the line. Area under the line of the velocity time graph or speed time graph. Velocity time graph or speed time graph. Look at the graph here. It is a trapezium shape. So area of the trapezium. So area of the trapezium here have sum of the two parallel sides into height. Here, look at the trapezium here. Two parallel side here. Here start from 15 to here it is 95. Here it is 95. So 15 minus 95. That means this is the A. Here it is A. Here it is A. A is 95 minus 15. 95 minus 15. 95 minus 15. 95 minus 15, 80. Minus 15, 80. So A is 80. A is 80 and B is 120 because here it is B. Here it is B. B is 120 and A is 80. A is 80. And here height is 42. Height is 42. Height is 42. So we can calculate the total distance traveled by the aeroplane by A, value of A 80 and value of B 120 into height 42. So by calculating this one, so 4200 meter. 4200 meter is the total distance traveled by the aeroplane. Yes, 42. Calculate the total distance that aeroplane travels. Total distance traveled is the area under the line. The area of the three parts of the graph must be added together. Left side, it is a triangle, so half into base into height. Half base 15 and height 42. Middle portion, it is a rectangular, so length into breadth 80 into 42. And right side, it is a triangular shape, half into base into height, half into 25 into 42. So total area 4200 meter. So total is the sum of three areas, 42 meter. Unit of distance is meter. Another important question: each airport has a runway that is about 500 meter long. When it lands, the speed of the aeroplane is 40 meter per second. 40 meter per second. Explain why the aeroplane should not use an aeroplane that has more mass and needs a higher speed for landing. So each airport has a runway that is about 500 meter long. 500 meter long. And when it lands, the speed of the airplane is 40 meter per second. Okay, now look at the model answer. Look at the model answer here. Faster the plane will A faster plane will need a greater stopping distance, which may mean the runway is too short. So remember, a faster plane will need a greater stopping distance, which may mean the runway is too short. A heavier plane will also require a longer runway. A heavier plane will also require a longer runway for the same reason. Stopping distance is around 500 meter from the graph right hand area. So all the runway is already being used. So a faster plane, first read the question first. Each airport has a runway is about 500 meter long. When it lands, the speed of the airplane is 40 meter per second. Explain why the airline should not use an airplane that has more mass, and needs a higher speed for landing. Because a faster plane will need a greater stopping distance, which may mean the runway is too short. A heavier plane will also require a longer runway for the same reasons. Stopping distance is around 500 meter from the graph, right part of the speed time graph. So all of the runway is already being used. Total for question 3 is 10 equal to 10 marks. Another important question. Question number 4. Look at the question first. A student cycles to school. The graph shows the stages A to G of the journey. It is a velocity time graph. Look at the graph. It is a velocity time graph. Describe the motion of the student during B and T. B. Look at the graph first. It is a velocity time graph. At B, the velocity remains same, 5 meter per second for a while. So it is a constant velocity. And D, here velocity is 0, so it is represent at rest. Describe the motion of the student during. The student cycles at constant velocity of 5 meter per second. So at B, stage B, the student cycles at constant velocity of 5 meter per second. Constant velocity 5 meter per second. 5 meter per second, constant velocity. Here is constant velocity. And D, the velocity is 0. That means the cyclist at rest. So you can write constant velocity or you can also write uniform velocity or constant velocity, and here you can write at rest. Now State how the graph shows that acceleration for stage E is greater than the acceleration for stage A. State how the graph shows that the acceleration for stage E is greater than the acceleration for the stage A. Look at the graph here. The gradient for the line at stage E is higher, or it is more steeper than that of the gradient of the line at stage A. So the gradient is much steeper for stage E, which means there is a greater acceleration. So gradient of the velocity time graph or speed time graph represents the acceleration. So the gradient is much steeper for stage E, which means there is greater acceleration. Calculate the distance that the student travels in the last 10 seconds of the journey. Last 10 seconds. Look at the graph. We know distance equal to speed into time. This distance is the area under a velocity time graph. This is the area of the trapezium in the last 10 seconds. So here look at the graph. Here height is height is 7. Here height is 7. Height is 7 and A here A is also 7 and B A is B is 10. So area is 59.5. So the height is 7 and the sides are 10 second bottom and 7 top. 7 second top. So 59.5 meter. 59.5 meter. The total distance traveled is 106.5 meter. Show that the average speed of the journey is, we know average speed equal to distance moved, total distance moved divided by time taken. Total distance here 106.5 meter and total time Here total time about 27 seconds on the graph. So answer 106.5 divided by 27. So 3.94 meter per second. 3.94 meter per second. We know a unit of speed is meter per second. So answer 3.94 meter per second. Meter per second. So 3.94 meter per second. So total time is given by the horizontal axis on the graph. So average speed equal to 3.94 meter per second. We know average speed equal to total distance divided by total time. Total distance is 106.5 and total time 27 seconds on the horizontal axis on the graph. Now question number 5. Question number 5. Look at the question number 5. The rabbit runs across the road in front of a car. The driver applies the brake. State 4 factors that affect the chance of the rabbit escaping without being hit. Marks 4 here. State 4 factors that affect the chance of the rabbit escaping without being hit. Number 1, the time it takes for the driver to realize that there is a rabbit on the road and to apply the brake, that is the reaction time of the driver. So answer will be number 1, answer will be reaction time of the driver. Reaction time of the driver. Reaction time of the driver. Velocity of the car from which the braking occurs. So initial velocity of the car. Stopping distance of the car. Stopping distance of the car. The friction between the tire and the road surface. Friction between the tire and road surface. Friction between the tire and road surface. So state 4 factors that affect the chance of the rabbit escaping without being hit. So number 1, reaction time, the reaction time of the driver, velocity of the car from which the braking occurs, stopping distance of the car, the friction between the tires and the road surface. Now question number 6. The diagram shows some people waiting in a queue at a supermarket. The queue moves the crowd each time a person leaves the checkout. The person X spent 7 minutes in the queue before reaching the checkout. Person X. Here is the person X. Here it is a distance time graph, distance in a minute and time in distance in meter and time in minutes. First question, what is the initial length of the queue? Initial length of the queue. Look at the graph, initial length of the queue. Here it is 1, so it is 0.8, sorry, initial, here it is 1, so about 1.5 meter. So what is the initial length of the queue? The initial length of the queue is given by the total distance traveled to the checkout by the person. The initial length is the total distance traveled, 6.1 meter. initial length of the kiwi 6.1 meter. Explain how you could use the graph to work out the number of times person X is stationary. The horizontal section of the graph indicate that the time passes without person moving. So the person has a speed of 0. The number of horizontal section will therefore give the number of times that the person is stationary. The graph shows that the person is stationary 7 times. So 7 times. State the equation linking average speed, distance moved, time taken. We know average speed equal to distance moved, average speed equal to distance moved divided by time taken. Average speed equal to distance moved divided by time taken. Calculate the average speed of the person X in the kiwi. Average speed equal to total distance 6.1 and time taken 7 into 60, so convert second, and here it is meter, so 0.015 meter per second. Remember to the use total distance and total time to calculate the average speed, and convert the total time of 7 minutes that the person spent in the kiwi before reaching the checkout to second by multiplying by 60. So average speed equals to 0.015 meter per second. Here unit, remember unit of speed is meter per second. And question number 7. A golfer practices hitting balls on the golf course. Ball X rolls along level ground as shown in the diagram. Add a level arrow on the diagram to show the direction of the two forces acting on the ball. Two forces here. Remember weight. Here center of the gravity of the spherical ball is downwards from the middle point. So here it is center of gravity. So remember weight acts from the center of gravity. So weight acts downwards, and remember there is a reaction time. When any object is placed on a surface, then surface will give an upward force which is exactly equal to the weight. So reaction force or normal reaction force, and the ball roll forward or right direction. So there is an air resistance in the left direction, and there is a friction also in the left direction. So air resistance and friction is two opposing force against it. They act against the motion of the object. Explain why the ball X slows down and stops. Friction and air resistance are acting on the ball, but there is no forward force being applied. This means that the forces are unbalanced, so there is a resulting force. So we know F equal to ma, there must be an acceleration due to the resultant force. In this case it is deceleration, since resulting force in the opposite direction to the motion of the ball. The golfer hits the ball Y at an angle into the air. He gives the same initial kinetic energy as the ball x. Suggest why the ball y travels much further than the ball x before it stops. The friction in the air is much lower than the friction of the ground. This means the resulting force y is lower, so it takes longer for the deceleration to stop. The mass of the ball y is 45 gram. The golfer gives the ball 36 joule of kinetic energy when he hits it. State the equation linking kinetic energy, mass and speed. We know kinetic energy, state the equation linking kinetic energy, mass and speed. Kinetic energy equal to half into mass into velocity square. So we know kinetic energy is denoted Ke equals to half into half mv square. That means half into mass into velocity square. Calculate the initial speed of the ball y. Rearrange the equation for the velocity and substitute the value of energy, kinetic energy and mass, remembering to convert 45 gram into kg by dividing 1000, multiplying both sides of the equation by 2, divide the mass to give the velocity square. So velocity square equals to 2 into kinetic energy divided by mass. So velocity equals to root over 2 into kinetic energy divided by mass. 2 into 36. Here kinetic energy is 36 joule divided by mass 45 into 10 to the power minus 3. So 40 meter per second. 40 meter per second. 40 meter per second. Last question. Ball y reaches a maximum height 35 meter. Suggest how the golfer should hit the ball y so it can reach a greater height. Hit the ball with a larger angle. So hit the balls with a larger angle. Hit the ball with a larger angle. Hit the ball in such a way that more energy is transferred to it. Hit it with a greater speed or velocity or force. Okay, no more today.